action potential arrives at the synaptic knob. It allows the calcium channels in the membrane to open, causing the calcium to flood in and move the synaptic vesicles filled with acetylcholine to the outer membrane. Then, through exocytosis, acetylcholine is released into the motor end plate and is picked up by the receptors on the motor end plate, allowing the potassium sodium ions to open, pushing the sodium into the muscle fiber while the potassium is pushed out into the synaptic cleft.
As we arrive to the muscle, it is composed of fascicles, myofibers, and myofibrils. The action potential travels down sarcolemma into T tubules and stimulates the release of calcium from the terminal cisternae of the sarcoplasmic reticulum into the sarcoplasm of the muscle cell. Calcium floods over the thin filaments and binds to troponin, pulling tropomyosin off the active site on the actin.
Calcium covers the thin filaments and connects to the troponin, pulling tropomyosin off the active sites on the actin. The high energy myosin head connects to the exposed active sites on the actin chain, forming a cross bridge. The myosin then begins to pivot into a low energy state where ADP is released, moving the thin filaments over the thick filaments. This is called the power stroke. After the power stroke is performed, ATP binds to the myosin head, causing it to pull away from the active sites on the actin. The myosin head then becomes energized and ADP is converted to ADP, resulting in. As the muscle begins to relax, calcium is pumped back into the sarcomere and is attached to calsequestrin, allowing the tropomyosin to once again cover the active sites on the actin, resulting in the relaxation of the muscle.